There is a question so simple that almost everyone believes they already know the answer. Why do you exist? Not why your life has meaning. Not why you were born into a particular family, but why a universe made of lifeless particles ever became capable of producing someone who could ask that question. It sounds ordinary until you look at it through the eyes of science, because the deeper we explore reality, the stranger our existence becomes. Imagine that, for just a moment, you are given an impossible ability. You can restart the universe again and again and again. Each time, everything begins from the same, unimaginably hot beginning. Galaxies slowly emerge. Stars ignite. Worlds are born. Then you ask a simple question. How many times would a universe like ours create? Would it happen every time? Most people instinctively think so. After all, if the laws of physics remain the same, shouldn't history simply repeat itself? Surprisingly, modern science suggests otherwise. Even if another universe began with the same physical laws, the smallest quantum fluctuation, the tiniest differences in the motion of matter, would gradually grow over billions of years. A single asteroid misses a planet. A single star forms slightly earlier. A nearby supernova explodes thousands of years sooner. A species evolves differently. An ancestor of yours never meets another. One conversation never happens. One child is never born. And suddenly, you disappear. Not because anything dramatic happened, but because the universe unfolded, just a little differently. Your existence is not the result of one extraordinary event. It is the consequence of countless ordinary events, all occurring in exactly the way they did. And the farther we travel into the past, the more impossible that chain appears to become. Tonight, we're going to follow that chain, not through mythology, not through speculation, but through everything modern science has discovered about the history of reality. A journey stretching back, not thousands of years, not millions, but almost 14 billion years. Long before Earth existed, before the sun, before our galaxy had taken its familiar shape, before there were planets, before there were stars, before there were even atoms. There was a universe so young that time itself had barely begun. For centuries, people imagined the universe as something eternal, a stage that had always existed, infinite, unchanging. But during the 20th century, that picture began to collapse. Astronomers noticed something extraordinary. Nearly every distant galaxy was moving away from us. Not because our galaxy occupied the center of the universe. It doesn't. Instead, space itself was expanding. Imagine drawing tiny dots across the surface of an uninflated balloon. As the balloon grows larger, every dot moves away from every other dot. No single dot sits at the center of the expansion. From the perspective of each one, everything else appears to be moving away. The universe behaves in much the same way. It isn't galaxies racing through empty space. It is space itself, slowly stretching. If the universe is expanding today, then logic suggests something remarkable. Travel backward through time, and everything becomes closer together. Galaxies approach one another. Clusters merge. Distances shrink. Continue far enough. And eventually, the observable universe reaches a state beyond anything we experience today. Hotter than the center of any star. Denser than anything found inside a black hole. Not an explosion inside space, but the beginning of space itself. This event became known as the Big Bang. The name is somewhat misleading. It encourages us to imagine an enormous explosion occurring somewhere in an already existing universe. But there was no empty room waiting for the explosion. There was no outside, no surrounding darkness, no distant observer watching events unfold. Space, time, energy, and every location that would ever exist all emerged together. The question, then, is not what exploded. The question is, how did a universe capable of producing stars, planets, oceans, forests, music, mathematics, and conscious mind emerge from such an astonishingly simple beginning? That mystery has driven generations of scientists, and every answer has revealed something even more unexpected. Because the early universe was almost unimaginably simple. There were no galaxies, no chemistry, no colors, no sound, no life. only energy, expanding, cooling, changing. Yet hidden within that simplicity were the rules that would shape everything to come. Not instructions, not a blueprint, just a small collection of physical law. Gravity, electromagnetism, the strong nuclear force, the weak nuclear force. Only 4 fundamental interactions. Everything you have ever touched, every mountain, every cloud, every living cell, every human thought, every civilization in history emerged from those same 4 laws, acting over billions of years. That realization is both beautiful and unsettling, because it means complexity did not arrive from outside the universe. It emerged naturally, step by step, from astonishing simplicity. But there is another question, one that physicists still debate today. Why do those laws have the values they do? Why is gravity exactly as strong as it is? Why do atoms remain stable? Why do stars burn slowly enough to allow planets to form? No one knows. Perhaps those values could never have been different. Perhaps countless universes exist with different laws. Or perhaps the answer lies in a theory that humanity has not yet discovered. Science has not solved this mystery, but it has revealed something extraordinary. If those laws had been even slightly different, the universe might have remained forever dark, and our story would have ended before it ever began. Imagine holding a handful of sand. Now imagine that every grain represents an entire galaxy, not a single star, but hundreds of billions of stars. The observable universe contains far more galaxies than grains of sand you could ever hold in your hand. Its scale is almost impossible for the human mind to grasp. Yet the greatest surprise is not its size, it is its simplicity. At first glance, the universe appears endlessly complicated. Galaxies collide, stars explode, black holes consume matter, planets orbit their suns with remarkable precision. Life emerges, civilizations rise and fall. But beneath all of this complexity, the universe follows a surprisingly small set of rules. Every atom obeys the same laws, whether it exists inside your body, on the surface of Mars, or in a galaxy 10 billion light-years away. Nature has no special exception, no hidden shortcuts. The same gravity that causes an apple to fall also guides the motion of galaxies. The same electromagnetic force that binds atoms together allows your eyes to detect light that began its journey millions of years ago. There is something profoundly elegant about that idea. The universe does not become more complicated as it grows larger. Instead, it repeats the same simple rules across unimaginable distances. And somehow, those simple rules create extraordinary beauty. But beauty alone cannot explain our existence. There is another ingredient: time, an unimaginable amount of it. Human history feels ancient. Recorded civilization stretches back roughly 5,000 years. The pyramids seem timeless. The Roman Empire feels impossibly distant. Dinosaurs disappeared 66 million years ago. Yet even that enormous span represents only a tiny fraction of Earth's history. And Earth itself is only about 1/3 as old as the universe. Cosmic history unfolds on a scale that makes all of human civilization appear almost instantaneous. If the entire history of the universe were compressed into a single calendar year, the Big Bang would occur at the first moment after midnight on January 1st. The Milky Way would begin forming in early spring. Our sun would not appear until September. Earth would form only days later. Complex life would arrive in December. The dinosaurs would vanish on December 30. Every city, every empire, every invention, every language ever spoken would fit within the final seconds before midnight on December 31st. Your entire lifetime would be less than the blink of an eye. This perspective is both humbling and strangely comforting, because it reminds us that we are participants in an unfolding story far older than ourselves. The universe was never in a hurry. Stars required hundreds of millions of years before they began to shine. Galaxies slowly assembled through gravity. Nothing happened instantly. Everything emerged through patience. Perhaps that is one of the greatest lessons nature offers. Complexity rarely appears all at once. It grows, slowly, one small step after another. As the newborn universe continued expanding, its temperature gradually fell. Within minutes after the Big Bang, the first atomic nuclei had already formed, mostly hydrogen, some helium, almost nothing else. No carbon, no oxygen, no nitrogen, no iron, no calcium. If you had somehow visited the universe then, you would have found no possibility of life. The ingredients simply did not exist. For hundreds of thousands of years, the universe remained an intensely hot plasma. Electrons moved freely. Light constantly scattered in every direction. Although photons filled the cosmos, they could not travel very far. The universe was opaque. It glowed brilliantly, yet nothing could truly be seen. Then, about 380,000 years after the Big Bang, everything changed. As temperatures continued falling, electrons finally slowed enough to combine with atomic nuclei. The first stable atoms formed. Suddenly, light was free. For the first time in cosmic history, photons could travel across the universe without endlessly colliding with charged particles. That ancient light still exists today. It surrounds us even now, invisible to our eyes, but detectable by sensitive instruments. It is known as the cosmic microwave background, a faint whisper from the infancy of the universe, a photograph taken before stars, before galaxies, before planets. When scientists first mapped this ancient light in detail, they expected near perfection. Instead, they found tiny imperfections, minuscule fluctuations in temperature, only a few parts in 100,000, almost nothing. Yet those tiny irregularities changed everything. Gravity noticed them. Regions containing slightly more matter attracted slightly more matter. The denser they became, the stronger gravity pulled. The stronger gravity became, the faster those regions grew. Over hundreds of millions of years, those almost invisible ripples transformed into immense clouds of gas, then into galaxies, then into stars. Without those tiny imperfections, the universe would have remained forever smooth, beautiful, perhaps, but empty. No galaxies, no planets, no observers. Once again, our existence depended on something astonishingly fragile. Not perfection, imperfection. The smallest irregularities in the earliest light became the largest structures in the universe. Sometimes, the things that appear to be flaws become the very reason something beautiful can exist. The first stars were now beginning to ignite, and inside their brilliant hearts, the universe would attempt something it had never done before. It would begin creating the very atoms that one day would become you. The first stars were unlike anything we see in the night sky today. The universe was still young. Its vast clouds contained almost nothing but hydrogen and helium, the simplest elements in existence. Without heavier elements to cool these clouds efficiently, gravity gathered enormous amounts of gas before the first stars could finally ignite. Many of them were giants. Some were more than 100 times the mass of our sun. They blazed with extraordinary brilliance, flooding the darkness with light for the very first time. But their greatness came at a price. The more massive a star is, the faster it consumes its fuel. These cosmic giants lived only a few million years, compared to our sun, which will shine for about 10 billion years. Their lives were astonishingly brief, yet those brief lives changed the destiny of the universe forever. Until that moment, the cosmos was chemically simple. Hydrogen, helium, and little else. No rocky worlds could exist. No oceans, no forests, no living cells. The ingredients for life had not yet been invented. Nature needed a way to create them, and it chose stars. Deep inside every star, gravity performs an endless balancing act. It pulls billions of tons of gas inward with relentless force. At the same time, the star's core pushes outward. There, temperatures climb to millions of degrees. Hydrogen nuclei move so violently that they overcome their natural electrical repulsion and collide. When they do, something extraordinary happens. They fuse together. A tiny fraction of their mass disappears, transformed into pure energy. That energy travels outward through the star, producing the light and warmth that spread across space. Every sunrise on Earth, every ray of sunlight that has ever touched your face, began its journey in this process. Fusion is far more than a source of light. It is the engine of creation. As stars grow older, their cores become hotter and denser. They begin producing new elements. Helium becomes carbon. Carbon helps create oxygen. Oxygen leads to neon, then magnesium, silicon, sulfur, and eventually iron. Each new generation of elements builds upon the last, like an artist slowly adding colors to an empty canvas. Everything familiar to us begins to appear. The carbon that forms the backbone of every living organism, the oxygen filling our atmosphere, the calcium that strengthens bones, the silicon inside rocks, the iron flowing through human blood. Without stars, none of them would exist. Yet even stars have limits. Iron marks the end of their creative journey. Unlike lighter elements, fusing iron no longer releases energy. Instead, it consumes it. The balance inside a massive star begins to fade. For millions of years, gravity and fusion have opposed one another. Now, fusion weakens. Gravity does not. Within seconds, the core collapses. Matter falls inward at astonishing speed. Temperatures soar. Pressure rises beyond imagination. Then, the star explodes, a supernova, for a few brief weeks. One dying star can shine brighter than an entire galaxy, containing hundreds of billions of other stars. It is one of the most violent events known to science, but violence is not its greatest legacy. Creation is. Only during these extraordinary explosions can many of the heaviest elements in nature be forged. Gold, silver, platinum, uranium. The iodine in your body needs to produce hormones. The copper carrying electricity through modern civilization. The gold inside a wedding ring. The uranium powering some of our cities. Many of these atoms were born in the final heartbeat of an exploding star. Then, they were scattered across the galaxy. Millions of years passed. The expanding cloud mixed with countless others, enriched by generations of stars that had lived and died before. The universe had learned something remarkable. Nothing needed to last forever. Stars could end, so that something greater could begin. In many ways, death became part of creation. About 4.6 billion years ago, one small region inside one of these enriched clouds began collapsing once again. Perhaps a nearby supernova sent a shockwave through the gas. Perhaps gravity had simply been gathering material for millions of years. Scientists are still investigating the details, but the outcome is clear. At the center of the collapsing cloud, a new star was born, our sun. Around it, a vast disk of dust, ice, and gas spun silently through space. Tiny grains collided. Some bounced apart, others stuck together, millimeter by millimeter, then meter by meter, then kilometer by kilometer. Small objects became larger ones. Gravity took over once more. The largest bodies attracted more material. Worlds began to emerge. Among them, a small rocky planet orbiting at just the right distance from its young star. Not too close, not too far. A world that, at first glance, looked completely ordinary. It had no forests, no oceans filled with life, no blue sky, no birdsong, only volcanoes, molten rock, and a surface constantly reshaped by violent impacts. Few would have guessed that this harsh young planet would one day become home to poetry, music, mathematics, and minds capable of wondering where they came from. Yet all the necessary ingredients had finally gathered in one place. The stage was set. The universe had spent more than 9 billion years creating the raw materials. Now, for the first time, those ancient atoms would attempt something entirely new. They would try to become alive. The Earth was ready. At least, it seemed to be. The planet had cooled enough for liquid water to remain on its surface. Volcanoes released gases that slowly formed an atmosphere. Comets and asteroids may have delivered additional water and organic molecules. Rivers began carving through young continents. The first ocean settled beneath an unfamiliar sky. If you had stood on the shoreline of that ancient Earth, you would have recognized almost nothing. The air contained very little oxygen. The continents looked entirely different. The moon appeared much closer, creating enormous tides that swept across the planet. There were no trees to sway in the wind, no birds to fill the silence, no flowers, no fish, no footprints waiting in the sand. It was a beautiful world, completely empty of everything we normally associate with life. And yet, somewhere on this young planet, one of the greatest transformations in the history of the universe was about to begin. Exactly how it happened, we still do not know. This is one of the few moments in the story of existence where science remains wonderfully humble. Researchers have proposed several possibilities. Perhaps life began around hydrothermal vents deep beneath the ocean, where hot mineral-rich water poured through cracks in the seafloor. These environments contain energy, complex chemistry, and natural mineral surfaces that may have helped simple molecules organize into more complicated structures. Others suggest that shallow pools, repeatedly dried and refilled by rain, allowed molecules to combine in new ways. Some believe that essential ingredients arrived from space aboard meteorites, carrying organic compounds formed long before Earth itself existed. Each idea is supported by evidence. None has yet solved the mystery completely, and perhaps that is fitting, because the origin of life is not simply another chapter in science. It is the moment when chemistry became biology. Somewhere, at some point, a collection of ordinary molecules began behaving in an extraordinary way. They started making copies, not perfect copies, imperfect ones, and those imperfections changed everything. Whenever copies are made, small mistakes occur. Most accomplish nothing. Some are harmful, but every now and then, one tiny change allows a molecule to survive a little longer or reproduce a little more efficiently than the others. Without intention, without purpose, nature had stumbled upon a powerful principle: variation, selection, time. These three ingredients would shape every living thing that ever followed. The first cells were astonishingly simple, compared with the complexity of even the smallest insect today. They were little more than microscopic chemical factories, surrounded by delicate membranes. Yet inside those tiny boundaries, something entirely new had appeared. Information. Not information written in books, not stored in computers, but encoded in molecules capable of passing instructions from one generation to the next. Life had discovered memory for the first time in the history of the universe. Successful solutions could survive long after the original cell disappeared. Every generation inherited what the previous generation had learned through countless chemical accidents. Evolution had quietly begun. For nearly 3 billion years, life remained microscopic. That fact often surprises us. When we imagine Earth's past, we picture giant dinosaurs, dense forests, or strange prehistoric creatures. But for most of our planet's history, none of them existed. The world belonged almost entirely to single-celled organisms, invisible to the naked eye, yet endlessly transforming the planet. Some of these organisms developed a remarkable ability. They learned to capture sunlight. Through photosynthesis, they converted light into chemical energy. As a byproduct, they released oxygen. At first, oxygen was almost a waste product. It immediately reacted with iron dissolved in the oceans, forming enormous deposits of rust that still exist today. Only after millions upon millions of years did oxygen begin accumulating in the atmosphere. Ironically, this nearly caused a global catastrophe. For many early organisms, oxygen was toxic. Entire ecosystems disappeared. But evolution had encountered challenges before. Some organisms adapted, and those adaptations unlocked something extraordinary. Oxygen allowed cells to produce far more energy than ever before. With more energy, life could become larger, more complex, more adventurous. Cells began working together instead of living alone. Some specialized in movement, others gathered nutrients. Some became responsible for reproduction. Others formed protective layers. Individual cells surrendered their independence to become part of something greater, a single organism. Nature had discovered another secret. Complexity does not arise only through competition. Sometimes, it emerges through cooperation. And that simple idea would eventually lead to forests, whales, birds, and human beings. But there was still one astonishing leap left to make. Living organisms had learned how to survive. Soon, they would learn how to perceive. And with perception, the universe would take its first step toward becoming aware of itself. For billions of years, life transformed the Earth without ever asking a single question. It grew, it adapted, it spread into every corner of the planet, yet all of it unfolded without curiosity, without reflection, without the ability to wonder. A tree reaches toward sunlight, a flower opens at dawn, a fish escapes a predator. Each follows patterns shaped by evolution over countless generations, remarkably sophisticated, yet entirely unaware of the story that brought them into existence. Then, somewhere along the long path of evolution, nature crossed another invisible boundary. Brains became larger, nervous systems more connected, memory more detailed, the senses more precise. Eventually, some animals no longer reacted only to the world around them. They began building an internal model of it. They could remember, anticipate, plan. Among the many branches of life, one lineage of primates developed an especially unusual ability. They learned to imagine things that were not immediately present. They could picture tomorrow, recall yesterday, share ideas through increasingly complex sounds. Those sounds became language. Language became stories. Stories became civilization. And for the first time in the history of the known universe, matter began asking questions about itself. That may be the most extraordinary event of all. Not the birth of stars, not the formation of galaxies, but the moment when atoms, arranged in a particular way, became capable of wondering where they came from. Think about what is happening right now. As you listen to these words, billions of neurons inside your brain are exchanging tiny electrical signals. Each signal lasts only a fraction of a second. Each follows the ordinary laws of physics. No individual neuron understands your thoughts. None knows your memories. None experiences your emotion. Yet together, they create something that no single cell possesses, a conscious mind. Exactly how this happens remains one of the greatest unsolved questions in science. Neuroscientists understand a remarkable amount about the brain. They can observe neural activity. They know which regions process vision, language, movement, and memory. They can even predict certain choices before a person becomes consciously aware of making them. But one profound mystery remains. Why does all of that information processing feel like something? Why is there an inner experience at all? Why isn't the brain simply performing calculations in complete darkness? This question has become known as the hard problem of consciousness, not because consciousness is magical, but because subjective experience has proven incredibly difficult to explain using the tools of modern science. Perhaps one day we will understand it. Perhaps consciousness is an inevitable property of sufficiently complex brains, or perhaps an entirely new scientific framework still waits to be discovered. For now, we simply do not know, and that is perfectly acceptable. Science has never claimed to possess every answer. Its greatest strength lies in its willingness to say, "We don't know." Yet, throughout history, many mysteries that once seemed impossible eventually yielded to careful observation. Lightning, disease, the motion of planets, the age of the Earth. Each generation inherited questions and passed better answers to the next. Perhaps consciousness will one day join that list. Or perhaps it will remain one of reality's deepest enigmas. Either way, the journey continues. As our understanding of the universe has expanded, another remarkable realization has emerged. Everything that makes your existence possible belongs to a chain stretching back almost 14 billion years. The hydrogen in the water you drink was created only minutes after the Big Bang. The carbon in every cell of your body was forged inside ancient stars. The iron in your blood was born in stellar explosions that occurred billions of years before the Earth existed. Even the calcium strengthening your bones was assembled in stars that disappeared long before our sun was born. You are not merely living in the universe. You are made from its history. Every breath carries atoms older than the solar system. Every heartbeat echoes processes that began long before life appeared on Earth. In a very real sense, the universe is not something outside of you. It is within you. And you are one of the ways it has organized itself. One day, our sun will exhaust the hydrogen that has powered it for billions of years. It will expand into a red giant. Its outer layers will drift away into space. The Earth, if it still exists, will no longer be the blue world we know today. Far in the future, the stars themselves will gradually fade. Galaxies will grow darker. The universe will continue evolving in ways that no human being will ever witness. Yet none of that makes this moment less meaningful. If anything, it makes it more extraordinary. Because against odds so immense that they challenge the imagination, a universe that began as an ocean of energy became a place where questions could exist, where curiosity could emerge, where ancient atoms could briefly gather together, look up at the night sky, and wonder how it all began. Perhaps that is the greatest lesson modern science offers. Not that humanity is the center of the universe. We are not. Not that the universe was built for us. There is no evidence that it was. Instead, science reveals something quieter, something humbling. You are part of an uninterrupted story that began nearly 13.8 billion years ago. A story written in starlight, gravity, time, and change. A story that has never stopped unfolding. And although we still cannot answer every question, perhaps that is exactly what makes the universe so beautiful. There will always be another horizon, another mystery, another discovery waiting beyond the limits of what we know today. So tonight, as you close your eyes, remember this: the atoms that allow you to dream have crossed almost the entire age of the universe to be here. Your existence was never guaranteed, yet here you are, a brief arrangement of ancient stardust, capable of love, of curiosity, of imagination. And for one quiet moment, the universe is listening to its own story. Through you. Good night.